Okay. Hello, we're continuing A-star shit. This time we're gonna be a little bit more hands-off and just kind of let the video go. Because we kind of looked ahead and realized how much shit there is to do still. And also the fact that nav meshes kind of just does A-star automatically. So there's not really any reason to go too hard. I do
It's
still
pretty
have the...
abstract.
Yeah. It's very much just like explaining how a better system works, essentially. Like, it's giving you the backbone of nav meshes. Haas is now following once again.
You know what? Okay.
Why does this happen?
I'm gonna wear my mod hat for a moment to say, I looked at Haas and it said his account is deactivated.
What is going on? Who is this?
So I think maybe Haas
Well, it's not like he's
died.
re-following every time, right? Did he die right as he followed us? So he's just like,
Maybe he died right as he followed.
and then his soul is just constantly re-following us.
I guess so.
That's so funny that it just keeps telling us that Haas followed. We're getting so many new followers.
He's dead.
R.I.P. Haas. Thanks for following.
Thanks, Haas.
Okay.
R.I.P.
All right, we're gonna continue. We're gonna watch this here 10-minute video, and she's gonna tell us all about A-star. You can hear it and everything,
Okay,
right?
how are you
Yeah.
coping with A-star so far? Well, we haven't even got into the code yet, and there's an awful lot of code that we have to write, but hopefully it's going to seem
God.
quite familiar because we've
Nice.
gone through all the basics and how it works. So let's begin. Now, inside of this class, first of all, we need to grab hold of our actual maze so that we can get its map. So public maze.
Didn't we write a bunch of
Now,
code
this
last
is going
time
to be a
already?
little bit of a combination.
Yeah, I was
between
gonna mention
actually
that.
running
We
the
did
A-star algorithm
write
and
quite a
then
bit of
also
code,
showing
but
it, visualizing it on the screen.
at the end
So
of the
we're
day,
gonna
it's
have some
just
constructs that are just for all the number crunching and everything,
like
and then
it's
others that are
pretty
going to
like
show things up
contained
for you. Okay,
within
so first
this
of all, I'm
one
just going to add in
tutorial.
two
I think.
materials that we'll use to change our nodes
I don't think we
from one
need
color
it
to the
for
other as they're processed.
Mater.
So material closed
Public
material,
mater.
and you can probably guess what the next one is. Public material.
Oh, I
open
love that I can
material.
write a script called
Then
Mater.
we need to create our
That would be
two
allowed.
open and closed
Yeah, it's like
lists.
allowed, and I can
So
make
we're
that a
going to
type
have a
so that
list
later on I can
of
say
path
public
markers
mater.
Say mater dot
for open.
y'all
It
or
would
something.
be like a
List,
script
path
where
marker,
like like there's mating involved
and
in
then we
some
also
way.
need one for closed. So let's just
Ah.
copy that
So you'd write a mater script.
and make this closed. And then we
I
need,
need to get
bring
this
in our game
mater.
objects that are going to be our actual physical markers on the map. That we
Just
can
have
see.
a
So
function called like
public
prilosec.
game object
Yeah, exactly.
start. Public game
We gotta do
object
more of that.
end.
More meme
and
naming
public
structures.
Game object path
Dr. Peppa.
point or path marker or whatever it is. Okay, I'm just going to call it that. So let's just save this and we will
Public
switch back
override
into
Dr.
Unity.
Peppa.
It's always good to sort of take a pause and go back to Unity so that it will compile it and throw up any errors if you've got any along the way. Now, we'll go over to our maze that's
Okay,
in the
so
hierarchy.
this is
I'm
we're
using the
gonna need an
recursive
int.
maze that I used before. You can actually use any of these.
That's
And
such a good idea.
then
Make a
put it on your
tutorial like
find
that
path.
where
Yeah.
A-star
we just
at
name
the
everything the
down
worst
here.
name we can.
Okay, so you're going to need to put the maze in. Now, this
Yeah.
maze that you're passing in
Call
here
this
is the
one,
script that's generating the maze,
any
not
ints
this
in
maze
chat,
here. So we
brother?
want the recursive script down into this position here, so it will get a map created. Now you need a closed material and an open material, and these
This is
starting,
our pimpy
ending, and
array.
half point game objects. The package file that I gave
We
you to
will
get
do
starters from
public
have these
pimp
in it. So if we go into the
pose
assets prefab, you'll find
equals
there that there's a start
8
object, so you can just
F.
drag and drop that into start. There's an end, just drag and drop that into there. Now these are just cubes that I made longer and put different colours on, and then there's one for the path. Let's
How'd she do
Now
that?
if you go into materials,
How
you'll
you
find a
do
whole
that?
bunch of colours. We'll
Do that
use
again?
red for closed, and I'm going
She
to
made a long
use,
cube and
let's
put a
say,
color
we
on
can
it.
pick blue or green. I was using blue
What,
in the
just a
previous video, but I'll
prefab?
use green for my open material, so it's the same as I had
That should
when I was
make the
first
cube
demoing.
long.
Okay, so now let's
Go
go
back.
back into our code video, but I'll cubes that I made.
Look how long that cube.
It's the path, right? Or no, that's just a prefab.
It's so long.
Longer and put different colours on, and then there's one for the path. Let's put that there. Now if you go into materials, you'll find a whole bunch of colours. We'll use red for closed, and I'm going to use, let's say, well, you can pick blue or green. I was using blue in the previous video, but I'll use green for my open material. So it's the same as I had when I was first demoing. Okay, so now let's go back into our code. Now, these three things are our game objects that we're going to instantiate and then hold onto them inside path marker objects. Okay, so we'll create a path marker for the goal node, and we'll also create one for start. So path marker start node. We'll also need another path marker, and this path marker is going to keep track of the last point that we're at, so last position in this case. And then we're also going to keep track of a bool called done, which will be true when we've found our way to the end of the path. So let's initially set this to false, like that. Okay, so that's all of the things that we need at the top, okay, all of our variables. All right, so I'm just going to save that again, switch back to Unity and show you something before we continue. So if we go into our prefabs where I've got these markers and just click on one, if you go over into the inspector, you'll see that they are tagged as marker. I've done this so that we can remove them with a key press out of the map, which will come in useful in a moment. So what we're going to be doing is having the ability to be able to
I feel like I'm going to
remove
use
all
tags
and
like a
then
lot.
do the A star over and over without restarting our code.
I
which
feel like
we
I'm
can
going to
play
use that
around
like
with
too
and use
much.
the results. So let's create a void
It seems so
remove all
convenient.
markers, and this is just going to be
I haven't
real quick
really
loop that just destroys
had any
everything.
experience
So
with them.
game object
I just like every time I want to
array
like
of markers
have a collision only work on
equals
one
game
thing, I just
object
make a
dot
tag of that one
find,
thing
game
and then
objects
say
with
if other game object dot tag equals that, then do
tag.
it.
Make
You
sure you
know.
use game objects with the S, and that'll be marker. Okay, and then we'll just do a
This
quick,
kind of shit too. Remove all
then we'll
markers.
just do a quick for each game object M marker in markers
Ops.
destroy M. Okay, so that will be called shortly. Right, let's now begin
She's like,
our
shit,
search.
shit,
So
shit.
void begin
Typing it
search.
in. Oops,
So
that was
we
a
will
mistake.
allow this to
That
be
was a
called
mistake.
over and over again, as I said before. So every time we do, we're going to set done to equal false, and then we will run remove all markers. Okay, so now we can actually go about creating our goals and everything. So first of all, we have to pick two positions in the actual maze that are going to be our start and end. And we could do it quite randomly, where we just keep picking random values and seeing whether they are a space or a wall. And of course, use the space. A better way is to actually put all of the spaces or all of the maze locations that aren't a wall into a little list, shuffle that list because we've already created our shuffle method, and then just like pick them off the top. Okay, so we're going to create a list
in this one?
of map locations.
Or did we do that?
And
I think we did that in the
locations
maze.cs
equals new
Oh.
list
last lecture.
map location. Okay, we're then going to create our nested loops to loop around
I was
our
just like
map.
reading
So
about
we want a
list.
for int
I have
z
list
equals
open on
1
my
to
phone.
z is
Oh,
less
nice.
than our
Every time I
maze
go to the
depth
bathroom, I just read
minus
about list.
1, and then z plus plus. Same thing for x. So let's change that to x, and in this case we want our width, and make that x. And inside of here we're going to test if maze.map for that xz does not equal 1, then we will put it into our list. Locations.
So
dot
1
add
means it's
new map.
it has a wall there, I guess.
Location xz.
I don't
Alright, so
remember
now
that
why am I
logic.
going not equals to 1 rather than equals 0? The reason being, if you think back to our recursive algorithm that we created previously,
Yeah,
we were
I
using
don't
values of
remember
2
that
in some places,
recursive.
and we did go through and set them all to 0. But as you create more and more different algorithms for your maps and come up with different methods, you might actually want different values inside of that map. So even, for example, you wanted
Okay.
different sort of textures on the ground or something, you might have a whole code system going on. So we do know
That
that
makes
ones
sense.
are the walls, and the starting positions can be any
That's a
other
cat-like
value at
series
this
as
point.
well.
So that's why I've got not equal to
What,
1.
The
like-
map
So by the time we've gone
Oh,
through
yeah.
this, we now have all of these locations, and so if we just shuffle them,
and like
so locations
specific,
shuffle, that's
you
going
know,
to
values
give
and
us
stuff.
a couple of values
For
sitting on the
different
top of that
tiles.
list that we can go ahead and pluck out and use as the goal location and also as the starting location. So let's go ahead and do that. So after this shuffle, I'm going to create a vector 3, which will be our start location. And we'll set that to a new vector 3. And to get the values, we're going to pluck them out, as I said, the location. And we're going to give it locations at position 0 dot x, and then we can just put it 0 for the y value and locations 0 for the z position. Now, we're putting 0 as the height because I have done that with pretty much everything, that we're just zeroing it as a flat surface. So it's basically sort of 2D at least. And then once we have this location, we're going to instantiate our first node at that location. So I'm going to create a start node, and that's going to equal a new path marker, which will be a new map location, locations 0.x, locations 0.z, so the same as you're using for the position. And then we're going to send through a 0. Then we're going to 0 our G, our H, and our F values. And for the game marker, just come down a line so I don't go off the screen for you, we will instantiate the start location, and then we'll just put quaternion dot identity for the rotation, because that's not really important. And finally, the parent is going to be null, so we'll just put that there. And for the goal location, we do the same thing.
Jeez,
So
that's a
we'll
lot.
copy all of that, save typing it out again, put it down here. Make sure that we're talking about the goal location. The position of the goal location, we're going to use that as the second value in that locations array that we shuffled. So let's just set all of those values there to 1.
Oh, okay.
And then this node down here is going to be our goal node. Now, at the same time that we actually create the path marker, we're going to instantiate those prefabs. Okay, so this one here is actually going to be the end prefab that we sent through before. Okay, so now we can actually run begin search, and we'll be able to see those markers come up. So I'm going to do that down in the update. So just in here, let's put if input.getKey down is key code.p. Then we'll do a begin search. Just before we go and try this out, there's something that I haven't done that we need to do with our positioning, especially for the vector3 location of your starting node. Okay, so the instantiated game object. Remember, we have a map scale that we've been using. So if I run this now, you'll see your start location and your goal location right down in the bottom corner, because we haven't actually scaled up their positions. So for the actual map values, we're not scaling those up by the map scale, but for any positioning we do of objects. So what I'm going to do up here is put in multiply maze.scale, and then we want to use that value there and put it for
That's
our
just
Z
to compensate
location,
for if
and
we
also for
want
our
to scale
goal
up the
location.
maze on our own, or
Okay,
is
right, so
scale a
that's
thing
now
we could
going to give us
change?
a better location.
Yeah, I think
I
that
also just noticed that should be goal
what she
location
means
there
is
as well,
like
so that we can see the goal in the goal location. Okay, so let's save
the
that.
like
We'll switch
physical
back to
position
Unity.
in
Now
the
we're going
world
to have a look at the maze for a second
will
before we press
change
play.
based on the
The
scale, but
recursive
then
script that I've currently got
the
on, you'll
actual
notice
like
if you've got my
map
starter file
is
that
based
it's a
on
width
just
and
like a
depth of
grid
10. So it's only a
shape.
small maze, and I did that because it
So it's,
allows
like,
us
abstract,
to see
I
everything.
guess.
We can zoom right in. If you've got a really big maze and
Okay.
you're zoomed right out, you won't really be able to read any of the numbers that
I don't
come
know
up
what
on any
how
markers.
you would
Okay, so
access
once your maze comes up, just press the key.
maze.scale.
Make sure
Like,
you
I don't
click
know
over
if
here,
that's
because this is where basically the
the
input
That's what I was
maze
thinking. That was like a
there won't be
method
anything
she
showing in
made
this
or
window because
something.
I have turned off the FPC. So I don't
Yeah,
want that
let
sort
me
of
just
interfering at
I'll
the moment.
look.
So when you hit the P key, you'll get a start
Maze
location
open.
and you'll get an end location. And if you hit it again, remember you've got that remove all markers, it'll get rid of them, and it will just
Yeah, it's a
each
public
time
int.
reset the position so that you can actually play around with A star and see what it's like
That's pretty
starting
cool.
and ending at different positions. Okay, so I'm going to leave that there for this video. When we come back in the next one, we'll finish off our
I guess you would
A-star
need
and
it
put
in
our
like a
paths.
iterative thing like this, where it's like spawning a bunch of cubes. You have to know like what scale it is in the code to like put them in the right spot.
I guess I am a little confused by that. Like, would that respond to if we like scaled the map up in the editor or something? Like,
I think scaling it up in the editor would fuck it up.
okay.
Actually, it's impossible to.
Oh, right, because
'cause-
it's created on runtime.
I'll just try it while it's running. See what happens. And then I guess I'll also try the... So yeah, the scale doesn't do anything, because it doesn't have any... It's just an empty with a transform and then the recursive script that spawns the prefabs.
Yeah.
So that scale does nothing. And then this scale does nothing on runtime. But
that
I
makes
think-
sense, I guess. So, and I guess what is the scale then?
It's the... Yeah, so it does change before...
Is the scale like how big the maze that's generated is?
Yeah, I think the idea is that there's like an array, or I don't know, maybe not an array or a list, but something that's keeping track of like the X and Y positions of all these prefabs, and that's just like 0, 1, 2, 3, 4, you know, just like a regular grid, and then
Okay.
it's multiplying it by that scale so that they like go in the right direction, like multiplying the X by that number will push it over in that direction by that amount. if it's like if they're all vector ones, you know.
So that's why the other, the bit that generates the goal and the start would need to know the scale in that case.
Yeah, and it looks like that's, I mean, that is what she does.
Yeah.
Looking at the code, but also she applies it to the like the prefabs, like when she's making them. You know, it's like it's it prompts you for the scale on instantiate, or not instantiate, but what does she use? Oh, she uses create primitive. Huh. We don't really use that.
Now, what is that?
GameObject.create primitive creates a game object with a primitive mesh renderer and appropriate collider.
Oh wait, we did that for the thing that drags the tanks. You know, the thing that's like a head of the tanks?
Yeah.
I forgot we did use that.
That's kind of cool. It just gives you the mesh renderer and the collider, like in like one line. That's cool.
Keep that in mind for sure.
Okay, let's get back into this A-star algorithm and finish it off. So we're still in begin search,
Is this the
and
final
we've created
part?
our starting
No,
and
there's
ending
another part
locations.
still.
So under here, what we're going to do is clear out our open and close lists. So open.clear and closed.clear. We're then going to add the starting position to the open list. So open.add start node. And then finally, if you remember, we created that last pos. We're going to set that to equal the start node at this point. Okay, so we're ready to start searching. Under here, let's create another method for searching. And this is really where you'll see everything we've been talking about so far come together. Okay, so void search, and we'll pass through the path marker of this node. Okay, the first thing we're going to do is to test if we've hit the goal. Okay, so this is the sort of ending condition for everything. So if this node dot equals, so there's one of our equals coming into play, goal node, then we're going to set done equals true and just return. Okay, and basically the goal has been found. Right, next we're going to loop through and find all of the neighbors. Okay, now this is very similar to what we were doing in all of our maze algorithms. Okay, how did we get the neighbor of the current position? Well, let's just go back into maze. We've already got that construct defined for us right here. Okay, so this is getting our neighbors
we didn't
for the map.
do this. We did not do that, right? She just gave us this. We didn't actually write through this.
Yeah, I don't remember writing through this.
Okay. I just wanted to make sure I didn't completely forget something.
Also use it for our A-star because we only want the horizontal and the vertical ones. However, if you want to be able to search on diagonals, there is no reason you can't put the diagonal coordinates in here, and the A-star algorithm we're about to write will work exactly the same. Okay, so let's start by looping through those map directions. So for each map location dir in maze.directions, let me scroll this up for you. We're going to find the neighbor. Okay, so map location neighbor is going to equal the direction plus this node dot location. Right, now before
Neighbor,
we can
one of
actually
those
process
words
this
that
particular
British people
neighbor,
spell
it needs
different.
to meet a few conditions. The first one is that it shouldn't
I
be
feel
a
like
wall.
that
If it's a
is.
wall, then we're just going to not process it and go to the next neighbor. So as a challenge, what I'd like you to do is write this if statement to check if the neighbor is a wall, and if it is a wall, then to continue. So
That's going to be the same as the previous thing, right? Where we would say, like, as long as it doesn't equal 1. I don't know where the code was. I guess I don't have it written out. But she did something where she checked in the maze thing if it equaled 1 or not. Like, if the nearby thing equaled 1. And 1
Yeah.
is supposed to be tagged as a wall. I don't remember what that thing is. I'd have to scroll back to the previous video, and it's not worth it. That is what I remember of that, though.
pause the video now. When we come back, I'll type that up for you.
A little too early.
Okay, how did you go? Well,
Oh,
it's
yeah,
pretty
they do
straightforward.
spell it
If
different.
maze.map at the neighbor
Like
dot
gray.
x and neighbor dot z equals 1.
I don't know about gray.
It's a wall, and
I think
we'll
gray has
continue. So
two-
continue is just going to allow us to go to
Two true
the
spellings.
next map direction, which will take us to the next neighbor. Now, the next if statement that we're going to have to consider
don't know
is
what they
if
are, though.
the neighbor is outside the realm of our maze. Okay, so another challenge for you. Write this if statement to check If that neighbour is outside of where you want it to be,
Look, they spell neighbor
then also continue.
the American
video
way
now,
in the
type that in. When you
subtitles.
come back, I shall continue.
Oh yeah.
Okay,
But
how did
then
you go
in
with
the
that one? Well,
code
it's
it's written
if
different.
neighbour
Yeah, see right there. Weird.
dot x is less than 1, or
Very weird that they
neighbor
catch the neighbor dot x.
x is greater than or equal to maze dot width
Like they use the right.
or
Yeah, the dot. They just do
neighbour
dot.
dot z.
What does continue
Where?
after the if statement? The first if maze map neighbor x neighbor z.
I think that's the for each. That's part of for each.
Oh, okay.
Z is less than 1, or neighbour dot z is greater than or equal to maze dot depth. And if that's the case, then we're going to continue. Now, one final condition. If the neighbour
I don't
is
really
already
use
in
for
the
each,
closed
though.
list, then we're also going to continue because we don't want to process it. But we haven't yet put anything in any closed lists, even though we do have a closed list. So let's instead create our own method that checks if a neighbour is in that list. Okay, so just under the search, I'll put it down here. So let's put a bool is closed, and then we'll pass through actually the map location marker, and then for each path marker p in closed, we're going to test if p dot location dot equals marker, then we're going to return true. Otherwise, we're going to return false. Okay, now it seems a little bit long-winded the way that we're passing through a marker and then we're actually looping through our closed list, which has path markers in it, and then actually testing against a marker and the location of a path, because this is the way we have to do it. At this point up here, neighbour is just a map location. It's just a position on the map. We haven't given it a path marker. So it hasn't got
Oh, it's a
like an
for.
instantiation
This is
of one of those
interesting.
path game objects that we've passed through above yet. So that's
It
why
lets
we
you
have these
skip things
tests on a
in the
map
for
location
loop.
against whether there's a path marker
Continue.
with that location. Okay,
Yeah.
so down in here we can put another if statement in. If is closed, neighbour, and we're just going to continue.
So when
Next.
the continue goes, if maze dot map equals 1, it does that, or if that's true, then it'll just skip past the stuff past it. Like it'll just end the loop basically, so it won't do the
So it's like a
next two
return
lines.
kind of.
Yeah,
Okay.
but it'll still do the next loop anyway. It's different from break.
So it's
which
like
I
an
guess-
or.
Kind of. I think you could get the same effect with other code.
Yeah.
But
That's what I
this
was
is
thinking.
interesting. Because this is dealing with arrays too, so it's a little... Like, I feel like you'd need to guarantee that it goes through every time. I don't know.
We're going to calculate our
Learn
g,
something.
our h, and our f values. So float g equals, it's going to be the vector 2 dot distance from this node dot location dot to vector, and neighbor dot to vector dot to vector. So that's finding your Pythagoras. Now we've found the distance between the current node, okay, and its neighbour. So this node here is basically the one that's going to be next to the neighbour. But you need to find the distance that has been travelled the entire way up to that node and then beyond. So you have to do that and then also add in this node and its g value, which is going to allow you to move one from your current node plus add up all the path distance that you've accumulated along the journey. Right, and then we go to float h. Now this is the distance between where that neighbour is and the final goal. So again, we're going to use a vector 2 dot distance, and we're finding the distance this time between the neighbour dot to vector 2 and the goal node. Goal node dot location dot to vector. Okay, it's 2 vector, not vector 2, and that's all you need to do for your h value. And then float f. Now you should know what this is because it's probably the easiest calculation in the whole A star, and that is g plus h. So basically it's just a summary of our path distances or the costs involved in travelling it. Okay, so now we've got that done, what we can do is create a game object to put on our path for this particular spot. So this neighbour is going to get a open block basically. So game object path block equals instantiate, and we want that path p that we passed through before, and new vector 3. This is the position in the actual game world where we will put that. So it'll be our neighbor.x, and don't forget to multiply by our map.scale. Come back here, which is in maze.scale, and then at 0 in the y, and then neighbor.z multiplied by maze.scale, and then we want to just put quaternion.identity at the end of that. Now, the path block itself, or I should say the path, this game object, if you have a look at it, let's go back into Unity, this prefab for path, if you open that up as a prefab and have a look at it, you'll see that there's a G, an H, and an F text mesh attached to it, and that's how I'm displaying the values of G, H, and F. Of course, when you're using this in production to do A star, you don't have to worry about all the sort of interface and fancy stuff, but I want you to be able to see it as you step through. Okay, so that means our code needs to set those values. Let's go back into find path. So we've got our new path block here, and so I'm going to get the text meshes that are attached to that object. So let's just call it values equals path block.get components in children, and you want the one with the S in it so that you're getting multiple ones, and we want to get our text mesh children, and then you'll get them in the order that they come in. So the first one is G, the next one's H, and the following one is F, as they are attached to that particular prefab. So we can go
That's
values
a pretty cool
at 0
little
dot text
doodad.
equals, and then just put some text in there. I'm going to put a G like that, plus G.toString with a little bit of formatting, so we don't get something ridiculous with a lot of decimal places, like that. And then we just need these for the H and the F. So let's just paste that twice more. Go to value 1 for the H and 2 for the F, and this is H, this is F, and then this is H, and this is F. Almost finished the interior of this for loop. The last thing that we need
What is that actually doing? G.toString 0.00? Like, I guess it's taking the number and turning it into a string, but like,
Yeah, I don't know what that 00 is.
is that like, maybe it's like telling it to round or something?
Let me see. ToString. It's so weird how a lot of the stuff in C# is like in JavaScript as well. Like the same names. A string that represents the current object? What does that mean?
Well, the current object would be the letter, I guess, like G.
Yeah, yeah. So it would be,
Well, what arguments does it take?
yeah, it's, I don't see any arguments.
Weird.
ToString.
Because she did say it's to like clean stuff up.
Oh,
But-
okay, there's overloading.
Oh,
Yeah.
okay.
Let's see. I found ToString 1. Someone put in 1. That's it.
Maybe that is rounding then. Maybe if you put 1, it makes it like an int or something.
Yeah, that's odd. Values 0.text. I don't know. ToString. C#. Standard numeric format strings. Format specifiers. Yeah, I guess it's a format specifier. I don't know how to use it because it seems like all of these are like codes, like A1, C4, you know.
I think it is
But
decimal places.
Yeah, I think it's meant to like
It's like a
print in that
formatting, yeah.
way. Like,
So if it was just 2, it would be 2.00.
yeah, it's so weird. I'm just gonna search that line.
Yeah, that's what I just did.
Oh,
That's what I found on here. Somebody was asking how to... It's like the reverse of what we need. Somebody was saying, like, how do I round it? And then somebody said that as an answer, essentially.
yeah.
So yeah, it says if you run that on the int to convert it to a string representation of the int with only 2 decimal places. Someone also said string.format, but it's kind of the same idea.
Yeah, I'm looking at string.format. So you just use zeros and it replaces it.
So I think I get that then. Yeah.
Yeah, I've just never heard of that.
Me neither. Okay.
To do is to add the marker to our open list. But before we do that, we have to make sure that it doesn't already exist, because if it does exist, we just want to update its values. Okay, so it might already be in the open list, and then we're looking at it from a different point of view, so from a different node, it becomes that node's neighbor. We still need to update the G, H, and F
Neighbor?
values. Okay, so I'm going to create a new method to do that. And once again, we'll put it down under search, come down here, bool, update marker, map location, pos, float G, float H, float F, and then path marker. And then inside of here, for each path marker P in open, if P dot location dot equals pos, then we're talking about the same path marker. And then inside of here, we can just update its value. So P dot G equals G, P dot H equals H,
What?
and P dot F equals F. Okay, so
Jesus.
this just needs to be fixed up. P dot H, and then F, and then we also need to set the parent of that marker to the node that we're currently working on. So P dot parent equals our parent variable that we've passed through. Then we can return true, saying yes, we've dealt with it. Otherwise, we looped all the way through here, we haven't found it, so we can return false and then deal with it back in the other code. Okay, so let's go back up to our search where we will now use this update marker. And in here, we're going to put if not update marker, passing through the neighbor, the G value, the H value, and the F value, and then the node, so this node, which will then become its parent. Otherwise, open.add new path marker, neighbor, G, H, F, path, lock, and this node. Okay, phew, a lot of code. We're almost done. We're almost where we can actually test it, but not quite yet. So we've looped through all of these neighbors, and we've calculated their H, G, and F values, and we have essentially put them into the open list. What do we do next? Well, we have to pick one that's going to become the next node that we're focusing on, so the position that's going to generate the new lot of neighbors. What determines the one that's chosen? So which one in the open list do we get?
The F
Well, it's the
value,
one with
right?
the lowest F value.
Yeah.
So the easiest way to do that is to
Nice.
reorder your open list from the smallest to the largest F values, and we can use the link library to do this. So we set our open list to equal our open list dot ordered, or order by, and we're ordering by a value that is from p.f. That's basically what that says, and then dot make it back into a list, dot to list of path markers. Right, that's done. Next
What is
we
that?
can
Okay. You're ordering it by P to PF? I thought it was going to be like an ascending order or something. From the parent to the parent F. I guess it's just saying only.
Is that the parent?
Wait, yeah, what is
Where's P? Oh, path marker.
So I guess it's just saying order it relative to the F. But I guess you don't have to say ascending or descending. It just does that automatically. It has like a default.
Yeah, list has that stuff in it
Okay.
where you can just like
Select.
there's like what's it called? Methods. There's lots of methods.
the one at the top of that list, because it's going to be the one for smallest F. Okay, so path marker PM equals path marker open list dot element at position 0. So the one on the very top, let's make that into a bracket. Okay, then we can close that path marker. So we're taking it out of the open list and we're putting it into the closed list. So closed dot add path marker like that. Right, so we've done that. We've closed it off, and therefore we need to remove it out of the open list. Now remember, it's sitting on the top of the open list, so we can go open.remove at 0. Okay, so taking it out of one and putting it into the other. And at the same time, we're also going to set its material to that red color that we selected for closed. So pm.marker.get component renderer.material equals the closed material. Last but not least, we now need to set our last position, which was initially start, if you remember. Last pos, the node that will get run next, equals our path marker with the lowest F. So that next time we come and loop through into here, this node will be set down here to this last node. Okay, I think we're actually ready to run this. So let's go down into our update.
That was a lot.
What we're going to do down in here is use a different
Yeah.
key to step through our A star. So if input.get key down is, I'll use C, not for any
She's
particular
not
reason,
actually
except
gonna
for
run it
S
in
is
this
usually used for
video.
navigation. So I'll just pick a key.
She's gonna make us wait
and
until
then
the
we're
next
going
one
to
to
run
see
a search,
it run.
and we're going to pass through the last pause, which at the start will be the first node. And we'll come back and try this out in the next video.
How could you do that? That tease, dude. That's fucked up.
Last one.
Let's go.
Then we got nav meshes.
I feel like nav meshes is gonna be a lot easier, but I don't know for sure. Cause I've already done nav meshes. That's what makes me think it's gonna be easier. Like I played with that in Unreal before I really understood anything about it.
Yeah. I think the code
Sorry, what?
in unit. I'm excited to see what you could do like in the code with nav meshes.
Yeah. Because all I did with it was I could say like it would just I had a function that would just get a random navigatable point within the nav mesh, and then it would navigate to that point and then get a new one. So they were just roaming constantly, which I feel
I
like
don't know why,
could generally work.
but I have this specific thing that I always keep in my head for some reason, like an association, I guess, with nav meshes. Or I remember watching a streamer play this game called Bigfoot, where you hunt Bigfoot, and they figured out after like 45 minutes of looking for him that he was in a corner, like trying to get around the, like he was
He
at
was
the very
stuck
edge
there.
of the map, just like stuck on the edge of the map because his nav mesh fucked up. That's what I always remember. Is just
Okay.
like, but also to be fair, they did an update for that game where you can play as Bigfoot, and it's like much better. I think it's improving.
Yeah, that's good.
But either way, I
That's a
always
good
remember
example,
that,
though. Keep in mind
in
that kind
the-
of shit.
But I just remember that in the Bigfoot game, Bigfoot is fucked up. Like, they
That's the
fucked up
one thing.
the only thing about the whole game. Truly, everything else is secondary in a game like that.
How do you not get Bigfoot in Bigfoot?
Yeah, but now he has like a super jump and stuff.
Well, that reminds me. On the car ride just now, I took Dubber to his car. So it was like broken down somewhere, and
That sucks.
there was a car. There was a like an ad on the radio. That was just this guy that was like, "Hey Jerry, how's it going?" And then this guy was like, "It's going great, but I crushed my mortgage recently with whatever, some bullshit like that."
Yeah.
There's like an ad about thing. But I just thought if the conversation was like, "Hey Jerry, how's it going?" And then he's like, "It's going great, but I crushed my nuts." I just kept saying that and like laughing to myself in the car. And then I was thinking about if that was a dialogue tree that could happen in Mall King.
Yeah.
And I started thinking about it'd be really fucking funny if we could get this is borderline feature creep, but if we could get the like Oblivion like dialogue system in that game, I feel like that would
What
be
is
so
that?
funny. Because I wouldn't want to go hard with like the Fallout, like try to make it more advanced. But like in Oblivion, they have like a list of responses that are just like, you know, every NPC has like greetings, responses, you know, confrontations, etc. And like if they bump into another NPC, it'll just be like greeting, response, goodbye, goodbye, and then they walk away from each
Yeah.
other. And if we just had a bunch of preset things, so if it was like, "Hey Jerry, how's it going?" Or not Jerry, it would just be, "Hey, how's it going?" Would just be like one of the greeting lines.
Mm-hmm.
And sometimes the response is just insane shit like that, you know? Because that's so fucking funny in Oblivion when they're just like, they'll walk up to each other and be like, "Hi, how's it going?" And they'll just be like, have you heard about this guy?" And he goes, "Thank you." And they go, "Goodbye." And then they just walk away from
Yeah.
each other, like completely talking past each other.
That would be good.
If we could channel that energy, I think that would be really funny.
I was thinking about that thing we figured out in AI Dungeon, that scene of the like toy store with like a crazy person in the back who's selling the Gorg bar. The Gorg bar mech.
I forgot that's what
figure.
it's called.
I remember it. And
Well, I was thinking that lady that I drew that's in the big fluffy jacket could be the crazy lady.
Which one is that?
Here, I'll put her on stream right now. I just drew a lady in a big fucking fluffy jacket, and I realized she's pretty close to what I had in mind.
Oh, yeah.
For who the crazy lady selling the Gorg bar is. I feel like she fits the bill.
I think she should have big glasses.
Oh yeah, I could definitely fit in this design though, for sure. But anyways, Gorg bar.
I was thinking that could be a fun that could be like a once we get once we get a dialogue system down, we could like do an all day like weekend stream or something where we make a toy store and that
Make
lady
that encounter.
Yeah, and make the Gorg bar.
That might need to be like 3 or 4 separate jams, but we'll see. 'Cause building a toy store is like already. I feel like should it be one type of toy? Like, should it be like a yo-yo store? You know what I mean? Like, I feel like we have to kind of restrain that.
For me, that toy store interaction in the AI dungeon is the one that stuck with me the most.
Yeah.
I loved the guy coming up and being like, "Hey, what do you want to buy something? You want to buy something? It's financially financially." What is the line?
I copied the whole thing into the Miro. Hold on.
I remember I figured it out the other day. It was financially vital for my economic survival.
Yeah. He's like, please buy something, please. Hi.
He's like, what do you like, kid? Sports, gambling. I got a great gaming system, and you just like walk away from him. Yeah, I don't know why, but I definitely internalized that.
I definitely think we can make that work. I just have to pivot.
It's like a Simpsons character.
Yeah. We just got to make it not generic, just toys. It's got to be like one toy. Maybe even just like action figure store. Like that could be fun too, because that's just a bunch of little models for us to make. Like we could just sculpt a bunch of dumb little guys.
Well, I guess we didn't really think about where a toy store would go, though. Maybe a...
I mean, is that a cool kid? That's kind of a cool kid thing. I feel like action figures.
Maybe it's a GameStop copier, you know?
What?
It's a GameStop, like, clone, I guess.
Oh.
But, like, you know how GameStop has all those figures?
Yeah.
If you go hard in that direction?
I feel like it could fit in magenta. Magenta is what, decrease?
Oh, do you have the Miro up?
Yeah, I'm just not here. I'll show it on the stream.
Oh.
Or wait, here. There, now you can see it, right?
Oh, okay. Yeah.
But yeah, I was thinking, like, I guess maybe it wouldn't be decrease, but I was trying to think of a way if we could make, like, decrease the difference between man and plastic or something stupid like that. You know what I mean?
Yeah, I mean, it doesn't matter that much. I think the cool kid nerd dynamic is more important.
Increase.
It's like cool chaos. Kid. It's really the axis is cool kid nerd and then like inside kid, outside kid.
I guess there's also the difference of digital and analog. That's analog, right? It's not a digital thing.
Yeah, but I was thinking he had all these like 90s equivalents of futuristic looking toys, you know. Like I imagine he had like weird like gambling games that like are like handheld, like a handheld soccer game, but it plays like this weird casino game. And you just like get money on it, and that's it. Like there's no buying or anything. You just play to win. I imagine like he had Game and Watches with casino games on them, but they're all like really gross and grimy.
Yeah, I could see that. I guess it would probably. I mean, I still feel like it's analog just because they're like physical things as opposed to like. I don't know though. I guess it could fit in digital. then it's either blue, magenta, red, or yellow, right? Because it's a cool kid thing.
Oh wait, it could just be the robot store. Fuck it.
I guess
Why don't we
that's
just say that's the
true.
robot store.
Robot
and then
store.
The robot store has like a figure seller in the back.
You could just change robot store to figure store as well.
I think calling it a robot store is good. Because then it could, you know, instead of it just being like
Robot.
generic store with robots in it, it could be some sort of theme of like of robots. Like the theme is robots, but then you go in and they sell all these different Gorg bar looking things that can like move their arms back and forth like a robot.
Yeah, and they all have to be robots though. Still.
Yeah, of course.
Okay.
But you can use the robot theme as like a with the if you have or that's like a place to put the what
where did I put all my notes on the fucking toy store? Goddamn. Oh, Kayla,
imported
that's right.
goods.
Her name's Kayla, Gorg
Yeah.
salesman.
Did you happen to save that Chinese character?
Hello, mall kid. I hope you come to buy something. I hope so. Economically vital to my survival. Wait, who?
The Gorg bar. We translated it. It was Gorg and then a Chinese character.
Yeah, I have the
think
character. I have the character
Yeah.
right there.
Okay, good. I think I want to keep that in.
Yeah, I would love to call it that still. Great, give me $2,000 in $100 notes. Wait, I thought it was $600. Yeah, it's yours for $600. I transfer the money to your account at Sears. Yeah, I think Kayla the Gorg bar salesman. I think she could definitely be Kayla. Where is she? Yeah, her. Let me see. Did they give a physical description of her, of the Gorg bar salesman at all? Oh yeah, you find one that fires small blue foam pellets at 72 miles per hour. Toys, gambling. I got a killer gambling system we can set up. I'm into bear.
Yeah.
This is so good. A
Really?
slightly disheveled woman. She has long blonde hair and thick glasses. That's right. So yeah,
she did have glasses.
She's got to have she's to be a little messier, and she's got to have the thick glasses. But other than that, I think this could be our Gorg bar salesman. I'm still not sure if we're gonna have more guys like this that have like plants growing out of their head, or if that's just this guy. But whatever, we'll get there.
Yeah, I think I just wanted to figure out something to do with his head.
Okay, well let's continue on then. We're on the last part.
Welcome back to part 5 of the A-star algorithm. Now, although I said the concept's really simple, the code just goes on and on, but we're almost done. I think I might have actually said that in the last video. Anyway, what you've got so far, you should be able to run, so I hope you had a little bit of a look at it. But
Yeah,
if you
I mean, we're not really...
Going on, I'm just going to run it from where we left off in the last vid. So go over to your hierarchy, click on your maze, have a look down at the size of the maze we're generating, and it's really little. The reason why I'm making it little is so that when you run it, and you put your points in it, you can actually see them. So at any point, if you want to sort of update the values here to a bigger maze, you can. I just start out with small so you can see it. Okay, so let's just press play. We'll get our maze, and there it is there. Let me go over and zoom in on it. And press the P key first. Make sure you've clicked over the game to get your start and end, and then you hit C. And C is going to start generating your points. And look at that. You can see them moving around, finding which is the neighbours.
That is
for the
pretty
purple ones, and the
fucking
red
cool.
ones are the ones that become part of the path, or
Yeah.
at least the majority of them are, and go into your closed list. Now, if you hit P again, it's going to clear all those out because of the way we programmed it, and then you can start again and hit C and follow them around. You can even see some of them updating their values as they become neighbours of a different node, and the values need to be updated. Okay, so great. Now let's just stop playing. If you're not too interested in all of those G and F and H values, you can actually make your maze a bit bigger. So if we go back to our normal maze that we had for 3030 when we were first building them, and press play. Okay, now we have an enormous maze there. And if you hit the P key again, start and end, and then we hit C to go through, you can follow the algorithm as it's trying to make its way around the maze. And you can also see how it explores the maze and how it goes back and forward, continually figuring out which node is the fittest node for it to follow So it's hit a dead end and a few dead ends there now, and so it's now looking in this
It's
direction.
like a disease or
Instead.
something.
So fantastic.
What, you're not
Now,
going to
the last
complete
thing
it?
that we need to
Oh,
do
you
is
evil
to work
bitch.
out what the path is. So once we've actually hit the
How
end
could you not
point
finish
here,
it? That's
we
so
can follow
unsatisfying.
all the way
Figured it
back
out with
via
her
the parent
eyes.
nodes to
That's
get the
so
final path. Because
unsatisfying.
if you have a look
I'm
now at all
pissed.
You
these
don't
ones
know
that are
what
gonna be
it is
closed, that's
until
not our
she
path.
gets to
Our
about
path is
there, and then
simply
you're like, oh
working
yeah,
our
I
way
see where it's going.
backwards through all those best ones that we've found. Okay, so how
Oh
are we
my
going to
God.
find those? Well, back to the code.
I'm
Each time we
upset.
press C, we're going to do a search with our last position. Now, if we go back up to our search, the last position is set at the end, which is the marker from the open list with the smallest value. And then if we have a look at the top and remember what we did, is that if we're passing through this node and it's actually equal to the goal node, it's just going to return without doing anything and set done to equal true. So that means after we have finished finding the goal location, and what I'm going to do just down in here to make sure we don't keep trying to run that is put and not done. It's going to basically stop us doing anything when we press C.
Oh, so now it'll
Now, what
just
have we got at this
auto-complete
point?
it?
Well,
Is
if we
that
have a
the
look
idea?
at an example map, what you'll see
Oh, no,
is
never
a whole
mind.
bunch of
It's not
closed
what it's
I don't
paths,
know
all the
what,
red ones.
what that...
This isn't the path, as I've said. These are just all the ones that we've explored and could possibly be on the path. The ones that are on the path are the ones linked by that parent value that we added right up here. Okay, so here's our parent value in our path marker. So if we get our very last node, our
parent
goal
is P.
location node, and follow it
Just in
backwards
that
up
method,
to its
though,
parent,
right?
and get the parent of that one and the parent of that
Right.
one until you'll get all the way back to the
Well,
start, we will actually
no, once
have
it's, if
our
it's
A
called,
star
it
path.
sets parent.
Okay,
P.
so considering by the time this C key doesn't work anymore and done is equal to true, the value of last position is going to have the goal position in it. Taking that into consideration, we're going to use that to
Oh, so now
backtrack.
she's just going to draw the
We'll get our
goal.
stuff. Now,
Let's just let that go.
not the same. At the Z multiplied by
So she's just going to create a loop that
Begin
just
dot
goes
parent.
through the parent and draws the list, the
Start node.
fucking path backwards.
and you make different for this loop or efficient already. So let's have a look. I've got mine at 15 by 15. That's okay for demonstrating this. Let's press play. Hit the P key. Okay, so we have a start and an end. We're going to keep hitting the C key until it's found a path. And
Oh,
in
that
this
was
case,
way
actually,
harder
let's go
than I
a long way
expected.
around. So all the way up to the top and around that way.
It's going to like fill the whole
So
thing.
we've pretty much
Yeah.
gone over the entire maze. Right, so we're there. We can't create any more. And now we can hit the M key, and there is our
Actually,
path.
yeah,
So
this is a
the
weird
start
maze.
and
Like,
the
there's
path is
no...
followed.
It's
Well, I
one
should go
long
backwards, shouldn't I? That was the end, and we're following our
loop
parents
around the
all
whole
the way
thing.
around.
Yeah.
Okay, so there you have it. That is the A-star algorithm. And although the code can get a little bit complicated at times, the concept behind it is really straightforward and goes with the way that humans actually would plan a path. So I hope you enjoyed this section and got a lot out of it.
That was pretty cool. I did like seeing that. I definitely realized we didn't need to do that. We didn't really need to follow along with that one, I don't think. Okay, so next is on the nav meshes. Let's see how much there is to that. Oh, it's only an hour total. So we got introduction to nav meshes, from waypoints to nav mesh agents, and then following a player on a nav mesh and setting up off mesh links. So yeah, this is like the first thing I learned in Unreal as well, making it just chase you basically, which is just like the most
Right.
basic behavior. But now it'll actually, I did set up a thing technically to do this in Unity, but it just clips through everything. It literally just moves towards you, whereas here it'll actually navigate around shit.
Yeah.
I'm not sure on this, but I think agents, I don't know if that's only things that are walking on it, because I know there's a way you can set things as like an obstacle in the nav mesh. So for example, if I set all those props as an obstacle, then the AI wouldn't just like walk through a pile of boxes, you know, they would like walk around them. My idea, I remember back when we were doing the City Street program in Unreal, the problem was they kept fucking running into each other. They were just constantly running into each other. And I couldn't figure out how to get around that. And my idea was to make every other player like considered an obstacle. Have there be like a circle around them or a cylinder around them that's just an obstacle that other AI would know to avoid. And I couldn't figure that out. So I'm hoping that maybe that's actually a good idea and that'll be applicable here. But I guess we'll see. I mean, there's a thing called crowd sim, so she's definitely gonna get to that.
Yeah, that is cool.
But yeah, I don't
the
think
whole
we're gonna
project.
do nav meshes right now, right? Because we're close to an hour. Leave nav mesh for tomorrow or next stream.
Yeah, I got kind of distracted. I don't know why I wanted to, but I searched voice impressions on Fiverr.
Why?
I was thinking like, can anyone do? Can you pay someone to do? You don't know him, but Phil Hartman was a comedian and he died in the 90s, but he voiced the lawyer from The Simpsons. You probably know his voice.
Um,
And I wanted to see if anyone could do him on Fiverr, and no one can.
it's a
Or
shame.
no one advertises it. But I'm also very surprised that there's only 3 pages of impressions. Most of them are really bad.
You can they have demos for them too.
Yeah. I will do Family Guy impressions.
Are you showing Family Guy impressions?
No, he lost me. That's the thing with impressions. It only takes one little slip up and then it's like, oh yeah, this isn't them.
You learned that the people you meet are much more interesting than toys. You also learned that starting a fire is a sure way to meet people. That's such a great end of chapter line. I forgot about that. But yeah, I guess we're good. I need to start filling out this one more now. I'm gonna start working on this. I was thinking about clearing out one of the other Miro boards that we're not using and try to use that for my class. Because the jam one was nothing. There's nothing in there.
Yeah.
Well, now there's literally nothing. I deleted it.
So feel free. It's kind of annoying you can only do 5 though.
Yeah.
But it just means
But it's per user, right?
I think it's per group.
Okay.
If we upgrade it, I think we get unlimited.
But I just feel why would we ever need to upgrade? We have infinite space within the Miro, right?
Yeah, the only reason I would want... The only time it ever comes up for me is when I think oh, I'll try one of these, one of their templates. But I can't. I think that's what Jam was originally. I opened up a template that was supposed to be a Scrum thing or something.
There is a Scrum one as well. Jam was when we did the I'll Be Back Jam. We were putting the notes down for that. Remember the game jam?
Yeah. I forgot that was the name.
I copied it over here just because it's kind of funny having the old ideas here, but really we should probably delete all these eventually too. You can see all the different directions we were thinking to go with it at first. But yeah, I mean, I think that's that. We're at an hour. Do you have anything you want to show before we close the stream?
No, I tried to do a little bit more of the security guard, but I think I'm at a point where I just want to retry again with where I'm at. I always go too far with certain points, and then it's just a really annoying to clean up.
Yeah, I can feel that. Well, yeah, hopefully I'll start actually working on game dev shit again besides these jams. I've been so fucking busy today. This has been the busiest day I've had in so long.
Really?
Yeah. I haven't done anything. I got to play Rust for 5 minutes and then fucking Deborah called me. So now I'm probably gonna go to bed pretty soon, but I don't know. We'll see. I might stay up. Yeah, I'm definitely gonna play some Rust. I don't know how much.
I'm gonna do a little more Blender tonight. I want to get better at modeling again. I've let it fall out of play because I haven't been drawing or anything.
That's a good practice. Yeah, that's a good thing to practice for sure.
Yeah.
Because even if you make I feel like every character you make we can use basically, even if they end up sucking and you're oh, I don't like him. Unless it's very obviously poor modeling or something. Like if they just come out looking dopey, I feel like that's fine, right? Like we could have goofy,
Yeah.
weird looking guys
I
walking
think
around
the
the
main
mall.
problem, my main problem is I keep going for like I go like the next gen up in like poly count. I feel like from what we're aiming for,
I mean, yeah, I guess
and
I don't have like a super definitive answer for all of our poly counts either, because our
I
poly
think
counts
I
are
like,
kind of varied.
but at the end of the day, like you could spend a day decimating any high poly model into a low poly model. Like it would be like messy and you'd change like a lot of stuff, but at the end of the day, like I just need to get something out. I always like stop myself because it's like, oh, this doesn't match, you know, the two models that we've put out.
Well, let me see. Let me try to get like a. I could try to get like an average poly count, I guess,
Mm-hmm.
just to get an idea of what we're working with. But I think generally, I think Julia is the highest poly one, and then like Fridge Guy is like the lowest poly one. Let me see.
Julie has a bunch of extra pieces though.
Yeah.
A lot
So
of accessories
Big
and hair.
Jerry is 3K, well 3.6K, so about 4K. And that's, you know,
And that's a good model. That's a great model.
thank you. So yeah, around 4K is probably a good amount there. I think Julia was like 7K or something. Let me see. Yeah, she's 8K. So she's like double of what Jerry was, but she has all these like armor pieces and shit, and the hair. The base body is not that much, and also she just has like a more detailed like human shape, whereas Jerry's just kind of lumps.
Yeah. But that's good, I think. Like his what I like about his model is like it's got the cartooniness like built into it,
yeah, I think
you know.
as long as they can coexist, that's the wrong one. I think as long as they can coexist next to each other and look okay, I think it's fine. And I think Julia and this character, I think Julia and Minota and Jerry all can fit together, despite them all having pretty different poly counts. Yeah, Minota has 5K, so it seems
Yeah.
like just around 4 to 8K, like that range. Like if you go above 8K, there should be like an exceptional reason for it. It shouldn't just be a person that's 8K tries. You know what I mean?
Yeah.
They should have something weird about them that makes them have that many tries. And I
Yeah,
think Fridge Guy was like
I
really
gotta just
low.
draw more.
Um, oh god.
Everyone thinks they can do Joe Swanson.
Yeah, 3K for Fridge Guy. So actually, Fridge Guy and Jerry are pretty similar. I guess it's just I put more polys into women. Apparently, is my thing here. Dudes get like 4K polys, and then women get like 6K.
That was a thing. I was looking at a hand tutorial, and a guy was saying how like he, for like a feminine hand, he'll like taper more, and I feel like you need more polys for a taper.
Yeah.
You know, so maybe there's something to that.
I want to start modeling more too. I can't help but feeling like I'm gonna end up feeling like it's a waste, and I could have been doing like programming instead, because I know I need way more practice with programming. So I don't know.
I mean, if you're producing something, it's probably not a waste.
Yeah. But either way, if you want to too, like take any of the characters that I've sent, and like try to
Yeah.
make one of them, or if you want to just make your own OC, obviously.
I think what I might need to start doing is just drawing my own version based off of your drawings, so that
That's not a bad idea.
because it's hard for me, I think, to interpret other people's lines.
Well,
a
you
lot
could
of
go
times.
with the suit men too. The suit men,
Right.
those
yeah,
were your idea, and I just drew. I made them all have completely different looks as well, even though they're all bald. Did like this is my calculus professor. This is like God damn it! There's an actor that looks like this, and I'm trying to remember what he plays.
In my head, it's Moby.
Moby.
Yeah.
This is like Pixis from Attack on Titan.
Who?
This is General Pixis. I don't know. He's just the bald guy who looks kind of like this.
Your stream is closed. Oh yeah, yeah, yeah. I do remember.
And then this is like Casey Neistat. And this is Jason Statham. And then this is Xehanort. That's kind of the combos I ended up with. I wasn't intentionally doing that, but I feel like all of them remind me of somebody. But yeah, if I just pass this off to you and then you just pick one and then draw your interpretation of that and then work from there, that could be a good way to go about it.
Yeah, I think it'll just help me get things like in my head easier, like understanding the angles better. I keep fucking doing the thing of like going to the front and then going to the side and then going to the front, going to the side, and then
You should
like
stop looking at that loop.
the models get corners in the diagonal, you know, because I'm not looking at it at a diagonal.
Do you think I should start drawing like 45-degree angle ones or something, or like top
Maybe,
down
but
ones?
I don't even know how to interpret really, you know.
Because I did that at first. When I very first started modeling, I would draw top-down ones as well. But then I stopped doing that. But I feel like that could be helpful.
Yeah. At least for like showing
Brenda.
proportions of accessories to the body and stuff like that.
Man, old Brenda is so cursed, like, comparatively. Dopey ass.
Wama.
Yeah, how do you do a poncho? That's got me so worried.
Do you remember I did the poncho for the goblin?
Oh yeah.
It
How do you
was
weight
easy.
paint that? It just like folds into itself, basically.
Yeah, I just matched it to I matched it really close to the body, so it wouldn't hang at all.
I feel like it's just gonna like crumple up and like have a bunch of vertices like stabbing out of it and look all weird. I don't know.
No, I mean, what I did was I weight painted the body first and then extruded out the pieces, or extruded out the chest and made that its own thing, so it had the same exact weight as the chest did, so it like morphed fine. I guess we didn't do that many tests on it. It wasn't a perfect model or anything.
It got the job done though, and it was able to dance. I feel like dancing is like still the best test for this shit.
I think a poncho is pretty close to the shape of like the polys on the torso.
Okay, that's good to know. It's not something I need to worry about.
Not too much.
Okay, well, we're past the hour mark, and we have completed a star. So I'll go ahead and end the stream here, and we'll resume tomorrow with navigation meshes. Yeah, and then maybe if we've done any modeling or whatever, maybe we'll have something to show. I can't say for sure. I was thinking through doing like 2D hands for like a first-person controller, like how we would do that. So maybe I'll go through that eventually. I don't know.
Yeah,
Right.
I don't know about like Billboard. Is that what it's called?
Yeah, I guess. I was thinking I would just set up a big sprite sheet and then just build the animations inside Unity for each little
That'd be
contextual thing. But then that would have to be like a fucking 8K texture, right? To have like every single frame of these animations for all these different states and shit.
Well, if you're animating, you could like animate it in Unity, like the position and stuff, right? I guess
Yeah.
if you want like a really high fidelity frame thing, then yeah, I would.
Well, I'm just
imagine
thinking
it'd
of
be
like when you grab something, I want his hands to go like make a fist. When you dive, I want his hands to go out like in a Superman pose. When you're running,
Yeah.
I want them to kind of go like. But I think some of it could probably be done with like position scaling. Like maybe if there's like an idle kind of wave to them, or maybe even on the run if they kind of bob like this.
Yeah, honestly, if you just had like You just need like a couple poses for the hands, and you probably could do all the movement in Unity if you wanted.
Yeah, well, I'll have to get to that. I'll have to figure it out. We're gonna have a lot of work to do on that front. But yeah, I'll
Yeah,
call it there, I guess.
cool.
Thank you for watching. Goodbye.
Goodbye.